Hi everyone, today in Integrated Math 2, we're going to go over Chapter 8, Lesson 5. Here are the objectives. Make sure you write them down in your notes. Alright, let's go over properties of rhombi and squares. A rhombus is a parallelogram with four sides that are congruent. A rhombus has the properties of a parallelogram and two additional characteristics described in the theorems below. So, first thing that we need to remember is all four sides are congruent. With that, the theorems that we were talking about, if a parallelogram is a rhombus, then the diagonals are perpendicular. Remember, when we're talking about perpendicular, we're saying that the angles make up that 90 degrees, which in this case, they do. Because when AC is perpendicular with BD, which makes that 90 degrees. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So, if parallelogram NPQR is a rhombus, then each diagonal bisects a pair of opposite angles. So, as we see here, angle 1 and angle 2 are congruent, 3 and 4 are congruent, 5 and 6, and 7 and 8 are congruent. So let's check this out real quick. So properties of a rhombi. So as you can see here, we have the two segments. They intersect and they create that perpendicular bisector, so 90 degrees. You'll also notice that BE, this line here, and DE, this line right here, line segment I should say, they are both 3.14. They are both congruent to each other. And same for looks like C and EA. It's the same case, but these ones are 3.03. And it changes as I move it. But notice here that BAE is 42.66. And then we have EAD, which is also 42.66. These two angles are congruent. And that goes for EDC, which is congruent with ADE, which is exactly what we were just talking about. Alright, then we have a square. A square is a parallelogram with four congruent sides and four right angles. Recall that the parallelogram with four angles is a rectangle. A parallelogram with four congruent sides is a rhombus. Therefore, a parallelogram that is both rectangle and a rhombus is also a square. So think about it. The way I remember it is if rectangles and a rhombus had a baby, it would be a square. It's a little mix of both of them. And same with those properties and theorems. Conditions of rhombi and squares. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Then if one pair of consecutive sides is a parallelogram, are congruent, the parallelogram is a rhombus. And lastly, if a quadrilateral is both a rectangle and a rhombus, then it is a square. Let's just look over the square once again real quick. So no matter which way I move this square, the degrees are not going to change. And let's say I put a line segment here. So that says I, and I'm going to make another one. That one also says I, because they are congruent, they are the same. And if I was to find the measure of the degree here, hopefully I can get it. Notice it's at 90 degrees. And each of these are 90. And if I have one here, all these are going to be 90 as well.